Hello everyone. In today's video, we will talk about encoding categorical values. In machine learning, it is very necessary to prepare data before it can be fit to a particular ML model in order to improve its performance. When your data consists of categorical variables, encoding becomes a very crucial part of feature engineering process. Encoding is a process of converting categorical data variables into a form which is easily understood by machine learning models. So let us start. We will first import the data, import pandas as PD. Then we will create a data frame by loading a CSV file. And we will make use of the head function to see the first 5 rows of the data frame. As we can see, some of the columns are having numerical values and some are having string values, that is, their data type is object. We can also see it in the information of the data frame that these 3 columns are having object values. Now that our data frame is consisting of object values, it becomes very necessary to treat it by encoding it. So let us just first check out how many unique values these object columns are having. So df.sex.unique. This sex column is having only 2 unique values, and df.exang.unique. This is also having 2 unique values, and then there is slope. This is having 3 unique values. We are now able to see the level of categories in each of these object columns in the data frame. We will now move on to encoding. So there are 2 types of encoding that can be performed on object data type in a data frame. One is label encoding and the other is one-hot encoding. So we will first discuss the label encoding. Label encoding refers to converting the labels into a numeric form so as to convert them into machine readable form. As you can see in the image, in the height column, there are 3 categories: tall, medium and short, which are after label encoding represented as 0, 1 and 2. So basically we are just assigning numbers to all of the unique values in a categorical column. So label encoding can be performed in 2 ways. One is with pandas and one is by using the sklearn library. In pandas, we make use of the replace function for label encoding. So we know that this 6 column is having 2 values, 2 unique values, male and female. So we will represent male by 0 and female by 1. For that, to this particular column, we will apply the replace function. In its argument, we will write the values which we want to change with the new values, that is 0 and 1. Now if we will check out the data frame, the 6th column is now being represented by zeros and ones. So the first 3 rows were having male as the value, and the 3rd and 4th row was having female, and we can just check it here from the original data frame that we were able to label encode it. Same way, we can label encode other columns as well. Here we will represent no with 0, and yes with 1. Similarly, we can do for the slope function. Now in slope function, there were 3 unique values, which we will represent by 0, 1 and 2. As you can see, now in our data frame, all the object columns have been converted into numerical columns, and we can check it using the info function that we don't have any categorical variables in our data frame right now. So this is how label encoding works. We can implement the same thing in the data frame by making use of the sklearn library. For that, let's just reload the original data frame so that we now have the object values again in a data frame. With sklearn, we make use of the label encoder. So we will import from sklearn.preprocessing the label encoder. We will create an object of this class So now after creating the object of label encoder class, so now we will just fit and transform this object with the column of interest, that is the sex column in the data frame, like this. We are simply using fit transform, but you can either first decide to fit the data of the column in the label encoder and then transform, and or maybe you can just do it in one go using fit transform. So here we'll be just doing it in one go. Now if we'll run this cell, we see again that the sex column has been label encoded, and we can also check the classes, like the name of the classes, using the object that we have created here. So female and male are the classes. So in this, female is represented with 0 because this is the first class. So first class is represented with 0 and the male class is represented with 1. So as we saw in our original data frame here, the first 3 rows are male and the fourth one is female. And here the male is represented by 0 and the female is represented by 1. So in a similar way, here. So here the first 3 rows are represented by 1, as male is being represented by 1 as it is in the first position, and the female is in 0th position in the classes recognized by the encoder object. So female has been replaced by 0. So in similar way we can perform label encoding with other columns as well using the sklearn function. So that is how we can do it in both ways. That is, with pandas we can do it using the replace function and in sklearn we can do it with the label encoder class. So next we will discuss about one-hot encoding. In one-hot encoding, for each unique value in the categorical column, a new binary indicator column of ones and zeros are created. As can be seen in this particular image, the color column is actually categorical in nature, and it is having 3 unique values: red, yellow and green. And for each of these unique values, a corresponding column has been created. As we can see, there is a column for red, there is a column for yellow, and there is a column for green. And these columns are binary indicators in nature. That is, they indicate the presence of the particular categorical value in the data frame. As we can see in the first row, the value is red for the color column. So to indicate that in one-hot encoding, the first row for red has been indicated as 1 and the first rows corresponding to yellow and green are indicated by 0. It represents that the first row consists of the red value only, as can be seen for the second row as well. And in case of the third row, the place for the yellow column has been represented by 1, while the corresponding places for red and green has been represented by 0, which indicates that in the third row, the value is yellow. So this is how one-hot encoding works. Now, like label encoding, one-hot encoding can also be performed in two ways. One is with pandas and one is by making use of the sklearn library. So when we use pandas for one-hot encoding, we actually make use of the getDummies function. So we make use of the getDummies function pd dot. So to the pd.getDummies function, we pass the data frame. Let us just reload the data first. So we have categorical columns in our data frame. Now if we'll run this cell, we will see that for each unique value of the categorical columns in our data frame, a corresponding new column has been created, which is binary indicator in nature. That is, these are the columns of consisting of ones and zeros, indicating the presence of that particular value in the data frame. So as we can see in our original data frame, the first three values were male and the fourth value was female. So here we can see that the male column is the first three rows of the male column is represented by 1 and the corresponding rows for the female column is represented by zeros, indicating that female is not present in these columns and male is present. The same can be said for the exange column and the slope columns as well. But there's a catch in all this. That is, in label encoding, here if we see, one column was actually sufficient to indicate the place of the male and female categorical values. So why is that? That is because there are only two variables, so it can be binarized. The same is the case with the exange column. One column was sufficient to indicate whether exange is present or not. So while using getDummies like this, we are actually creating unnecessary columns for these two variables. Even for the slope column, see, in this case, the slope downsloping is 0 and the flat value is also 0. Now, if we didn't have this particular column, the last column, that is slope upsloping column, okay. So these two values being 0 represents that there is some other value. That is by default the upsloping value. Like if these two values, that downsloping is 0 and flat is 0, it indicates that there is an upslope. So we don't actually need the last column, or we can say we don't actually need the first column, because if we consider the third row here, the flat is 0 and the upsloping is 0. It automatically indicates that downsloping is present. So we don't actually need the third column in this case and the second column in these two cases. So for that reason, to reduce the number of column and hence the amount of unnecessary data in a data frame, we make use of the drop first argument of the function. we make it true and we pass it to the function. And now, as we can see, the sex column and the exams columns are represented by just one column. This is basically label encoding only, but the slope column is represented by two columns instead of three, because earlier we saw that there are three unique values, but in reality we actually need two to indicate the presence of these values in the data frame. So whenever in our categorical variable date columns, if there are only two values, then we can simply make use of the label encoder and be sufficient with that. But when we have more than two values, it is better to use the one-hot encoding to represent the data much better. That is because, as we can see in the case of label encoder, we are actually passing the values 0, 1 and 2. And in numerical sense, as we know, 2 is considered as greater than 1 and 1 is considered as greater than 0. So it introduces kind of a bias in the model, because the value which is replaced by 2 is considered to have more weightage, as 2 is considered greater than 1 in value. Okay, so to avoid such kind of bias in the model, we prefer to use one-hot encoding. Now we can make use of the sklearn function as well to perform one-hot encoding in on our data frame. So now we can also make use of the sklearn function to perform one-hot encoding to transform our categorical values. For that, we import from sklearn.preprocessing the one-hot encoder class. In the same way as in the case of label encoder, we will create an object of one-hot encoder class. So after creating the object, we will fit and transform the slope column. That is, we are going to one-hot encode the slope column of the data frame. And please pay attention that I am using double square brackets here to make it a 2D array instead of 1D array, because the one-hot encoder object expects to receive a 2D array as its input. Also, we will convert the result to an array in order to understand it better. Now we will run the cell. We can see that result is actually having three columns in it, representing the three unique values in the slope column. And to visualize it in a better way, we'll have to create another data frame using the pandas data frame function. The columns would be the category in the one-hot encoder object. You can just check out the categories here like this. In label encoder, we were using classes to get the category, but in one-hot encoder, we actually get the classes like this. So just copy and paste. This will be the name of our columns in the data frame, and the data will be the array itself. So now if we visualize it, this is something like this, like slope, down sloping, flat and up sloping. The same way it was here, flat, up sloping, and like before we pass the drop first equal to true. We had the downsloping as well. So that is how the one hot encoder works, and we can do the same thing with the other columns as well. Now that the data frame that we have created here, we can just simply merge it with the original data frame and delete that slope column from it, and we would have performed the one hot encoding with the data. Now there is one more thing that we can do with the one hot encoder class object that we have created. That is, if we want to reverse this result, then how would you do it? That is also very easy to get back to the original form of the data. What you need to do is, using the object that you used for one hot encoding, you will take the inverse transform of the result. So it will give you this value, upsloping, upsloping, downsloping, and if you will see the original data frame, these are the same values. The first two rows are upsloping, then like the third and fourth rows are downsloping, and then the fifth row is the flat. And the same can be seen here. The first two values are upsloping, the next two values are downsloping, and then there is flat. So that is how we can inverse the transformation that we have done. The same can be done with the label encoder actually as well. That is, but it should be noted that the same object that you used for the transformation should be used. So here, if we want to inverse transform, let's first do it this way. Yeah. So now we pass in the column and we get it back in the original form. So that is how we can perform encoding of categorical variables in a data frame. Let us just recapitulate what all we have learned. So whenever there is a categorical variable in a data frame, we need to convert it into a form which is understood by an ML model, that is in a numerical form. So for that we implement encoding. There are two types of encodings basically. The first one is the label encoding. In label encoding, we are just simply replacing each unique value with a particular number for that. That is, as in the case of this image that we can see, the height column is having three values, and all these three values are represented by a particular number. That is, if in this column the next value after short was tall, then it would have been represented by 0 only. So tall in the entirety of this column will be represented by 0, as medium will be represented by 1 and short will be represented by 2. So this is what is label encoding, and it can be done with pandas using the replace function as we have seen here, and we can also make use of the sklearn library. From that library there is this particular class called label encoder which can be used for this purpose. So using the label encoder, we can label encoder categorical variables in the data frame, and we can actually get the reverse also, like the inverse transform of the transformation that we have done. But it should be noted that this same object that you have used for transformation here should be used for the inverse transformation as well. Okay. After that, we come to one hot encoding, in which for each unique value, a new categorical column in the data frame is introduced, which is basically a binary indicator of the presence of that value in the particular rows of the data frame. So that can also be done in two ways, using pandas and sklearn. And in case of pandas, we make use of the get dummies function for that. And we should drop the first values that are created, because that is unnecessarily increasing the data in your data frame. Here we only had three columns which were object in nature, like having the object data type, but in real life we actually have quite a lot of them, and if for each of them we are increasing one column, then we are just unnecessarily adding data to a data frame and reducing the efficiency actually. And here we have only used just to show you, I have used the pd.getDummies function, but it is not actually being reflected like this into the original data frame. For it to reflect the changes introduced by the getDummies function, you need to assign it like this to your data frame. Now if you will run the code after that, you will be able to see that it is now being reflected in your original data frame, the changes introduced by the getDummies function. Then with sklearn, we use the one-hot encoder class in the same way that we did with the label encoder. We just fitted and transformed in one go, and I converted the result into a form that would be easy for us to understand. That is an array, and this was the result. And to better understand it, we just created a data frame, and this data frame as it is can be merged with the original data frame, and from the original data frame we can just remove that slope column in order to perform one-hot encoding. And here also we can take the inverse transform. Also you should note that in one-hot encoding, to get the classes we use the categories token, and in label encoder we simply use classes to access this. So this was all about encoding categorical variables. Thank you for watching, and we will keep posting more such informational videos.